In his book, Software Engineering at Google, Titus Winters defines software engineering as programming integrated over time. But what does that even mean? It's actually the calculus of decisions. Every single requirement, every design decision, every trade-off, every production incident, every single refactoring, all the team collaboration efforts, everything that goes into building that software system over time, that's actually engineering. Let's compare and contrast vibe coding that's quite famous these days with AI assisted engineering, which is what we have been talking about. So, what is vibe coding? Very simply, it's AI agents that get to write code for you, build for you, and make the software run for you, while you feel the vibes of bringing your ideas from imagination into reality. Now, compare that with the AI assisted engineering flow, in which you carefully break down the entire phase, the entire task into subtasks. You get to make the decisions. You get to brainstorm with the AI tool. Every single commit they produce, you get to review them, you get to course correct them. And very simply, the AI agents execute, you engineer. So this will give you the speed, productivity, the impact, and virtually make you limitless. So now let's talk about various dimensions that actually make a difference when you write code or when you do AI-assisted engineering, and concretely, what's the impact? So the number one factor is validation strategy. How do you validate what has the agent produced for you? So it might work on your machine, but it might not be suitable for production, and hence you might observe high bug escape rate. Second thing is error handling. So error handling is not simply throwing an exception or expecting an error code and comparing that and branching out. It's a lot of things. It's circuit breakers, it's timeouts in HTTP calls or any network call. It's actually handling explicit failures that can be handled or must be handled, and crashing when you must crash gracefully. So if you don't do it well, it poses a risk of catastrophic launch of your software. Another aspect of another aspect is the architecture decisions. With vibe coding, you see the emergent complexity from what the LLMs generate for you, and you accept it as a complex piece of software that just works. But you haven't done the real analysis. You haven't done the proper documentation, evolvable artifacts that will make this software grow. So when you deploy such a system, you are clueless. They are untraceable in production. What about velocity? Now, velocity is an interesting aspect. It will make you feel like with vibe coding, you are at a very fast speed, but that's roughly a honeymoon time of 2 to 4 weeks, after which you will observe a sharp decline in your progress. Because if you fix one thing, four other bugs will open up. If you try to add a feature, it might not be coherent and orthogonal with the other features in your application. So with AI assisted engineering, your progress is steady, you build it up, and the net outcome is much faster. And when it comes to the ownership, you will never own something that you don't understand, right? Imagine being in on-call situation in production um, during an incident and not being able to troubleshoot or reason about what's happening in your system because simply you don't understand the code base at all. Now, the last dimension we'll focus on is security and compliance. So you have to be compliant with the geographical region of your customers, the local regulations. You have to make sure that you do security by design, not as an afterthought. Otherwise, your application will be open for catastrophic attack vectors. You must be able to reason about the threat modeling against your applications, right? Because before you deploy something in production, you do pen testing, just like you do performance tests. So if you want to have a good time with your application in production and a good night's sleep, it's very important that you do security design very well. With vibe coding, it completely goes blank. So now you might be thinking, what's the value in vibe coding if it's that bad? I think it's still valuable. It's still useful. It's good for prototyping and producing precise estimations. You would otherwise be blindsided because of some complexity that you might run into while building software, right? So vibe coding might help you there to tap into the complexity of anything you estimate very quickly. And then AI-assisted engineering is important if you want to do high-quality production-grade applications. And this is the new software engineering.